morning, friends. I am here again for my course, which is Aircraft Systems. Today I am in lecture number 20, and the topic for this lecture is hydraulic fluids and its properties. As you know, I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have completed my 19th lecture in this course, which is Aircraft Systems. And if I talk about the previous lectures, in module 1, I have done with the different types of systems and their basic introduction, like airframe system, vehicle system, avionics system, and mission system. If you talk about the airframe system, I have covered the construction of wing, construction of fuselage, construction of empennage, and different control surfaces, how they are connected. If we talk about the vehicle system, I have covered the electrical system, oxygen system, anti-icing and de-icing system. In my module 2, firefighting system also. And now I am in module 3, and the module 3 consists of hydraulic and pneumatic system. So in this process, I am in the process of hydraulic system only, and the next classes I will be taking the pneumatic system. So here today I am basically focusing on the hydraulic fluids and their properties, and at the end I will go with some components of the hydraulic system. So now in this we have the revision. In this revision, if you see that we have revision, then hydraulic fluids in aircraft, types of hydraulic fluids, properties of hydraulic fluids, fluid power systems. So these are the things which I am going to cover in today's lecture. In the revision point, if you see the hydraulic system, their components and their advantages, I am going to discuss. I have already covered these all topics. So it is always the component of the hydraulic system. If you see the starting from the first one is the reservoir. If you see, this is the reservoir. From the reservoir, it will go to the pump. This is the pump. This is the pump. This is the reservoir. Then you have to go to the filter. This is the filter. Then after the filter, you will go to the NRV, non-return valve. Then you will go to the pressure reducer. Then you will go to the pressure IEF relief valve, and from here you will go to the actuator. From the actuator it will go to the filter again, and this is the return line. Okay, so this is the in the direction, this is the return line, and this is the actuator. So this is the basic system which I have already covered in my previous lecture. So just I want to revisit here, and these are the components. Means the reservoir is used to store the hydraulic fluid, pump is used to give the pressure, filter is used to filter the impurities of the hydraulic fluid, and RV is used to give only for the one directional flow. Pressure reducer is reducing the pressure as per the requirement. Pressure relief valve, if the pressure is excess, it will give the relief or it will release the excess pressure. Then the required amount of pressure will go to the actuator. In actuator, there is a piston and there is a rod. So this piston will move and there is also a selector valve. Here there is a selector valve. This selector valve will either this side or in this side. So this will move either this or this. This rod will move due to the pressure difference of this thing. And there are some advantages of the system. The hydraulic system, it is very compact system, and it reduces the effort of the pilot, smooth, and there are so many other benefits of this advantages. Now I will talk about the hydraulic fluids in aircraft. So hydraulic fluids used in aircrafts are relatively thin compared to the industrial fluids. They must also be fire resistance, means fire should not take place at any cost. At high temperature, it should be able to sustain, which is critical when the nearest fire department is 5 miles below, not a few blocks away. Hydraulic fluids used in aircraft, because you are flying, there is no firefighting system there. So you are flying 100 kilometers away, their firefighting team cannot reach. So you should make sure that there should not be any fire risk during flying. Hydraulic fluids used in aircrafts also differ from industrial application, because they must remain at minus 65 degree and up to 275 degree Fahrenheit. So minus 65, it means minus 6.5 degree centigrade, and nearly it is 275 degree centigrade. So it is accordingly, this we have to see that this much range your hydraulic system should work. At those temperatures, water and vegetable-based oil lubricant will freeze or boil. So if our aircrafts are using in this range, and in this range, our vegetable-based or lubricants will freeze or boil. If it is high temperature, it will boil, and if it is low temperature, as a minus 65 degree Fahrenheit, it will freeze. The primary hydraulic fluid used in a military and commercial aircrafts depend on the particular application and the environment. So what type of systems we have to use, this depend upon the what we are, in what situation we are going to fly the aircraft. Now we have some types of hydraulic fluids which are used in aircraft. First and foremost is military H5606, has been used on many aircraft for over 50 years. It is still in use on some US Air Force planes and business jets. However, it is highly flammable and may have been responsible for loss of military aircrafts in the past, and therefore is not used as frequently as before. So this one, fire chances are very high because it is not able to go for a higher temperature zone. So initially few accidents happen, and now this hydraulic fluid is only restricted to a very limited use in military aircrafts, that is to a very low performance of the aircraft. Next very important hydraulic fluid is military H83282. So hydraulic fluid used in aircraft has been used by the Air Force since 1982, and the primary fluid used in Navy aircraft since the late 1990. So in US Air Force, they have used military H83282. They have not using military H5606 due to its flash point is very low. So now in this, US Air Force has started using this from 1982, and the US Navy has started from late 1990s. Its popularity is primarily due to it being much less flammable than 5606. So the major advantage is fire resistance. This you can see, it is a much less flammable, means fire will not take place like 5606. However, it is more viscous at low temperature. So there are some disadvantages. At a low temperature, it is quite thick. The viscosity of this fluid is quite high. So this is the disadvantage, with a lower limit at only 40 degree Fahrenheit, 4.5 degree centigrade. Okay, so we can use for a lower temperature, it is not good. However, for higher temperature, it is good. So the chances of fire is always at higher temperature. However, the performance is depends. Sometimes our aircraft goes in a very high altitude. Their temperatures are in very good, very low. That may be in less than 4.5 degree centigrade or 40 degree Fahrenheit. So if it is like this, then the viscosity of this fluid military H83282 will be quite less, and this will be trying to make this thing denser. Military H87257 is a newer formulation and used in C-135 aircraft, E-2 and U-2 aircraft. So this is another type of fluid, hydraulic fluid, that is H87257. This is also used by the US military aircraft. Is new formulation and used in this aircraft 135, E3 and U2 aircraft. It is also less flammable than 5606 and is able to remain fluid down to minus 65 degree Fahrenheit. So in this, up to this temperature, it can work nicely. It has become the more popular hydraulic fluid in modern aircraft. So this fluid is used for the modern aircraft, this military 87257. This is used nowadays. Next one is the Skydrol. It is a trademark of the company. It is a phosphate ester technology manufactured by Eastman Aviation Solution and has become popular in the industry as the first fire resistance hydraulic fluid. So this Skydrol is fire resistance. There is no chances of fire for a given range of temperature. So this has a very good property. So it is a phosphate ester technology. So this makes that phosphate, that fire resistance, it is for a very high temperature also. Fire may not take place. Next is Hi-Jet. It is also a name of the fluid. Is manufactured by ExxonMobil and is compatible with all approved type 4 and type 5 hydraulic fluids. So it is a type 4 and the type 5 hydraulic fluids. Elastomers and other hydraulic systems material. Hi-Jet 5th is a fire resistance phosphate ester hydraulic fluid that can help mixed fleets extend the life of their hydraulic system. Mobile Hi-Jet 5th is approved for all commercial 5000 psi hydraulic pressure aircraft system. So normally we use the hydraulic pressure 3 to 4000, but nowadays for the modern aircraft we use 5000, 6000, even 8000 psi also hydraulic fluid. Such type of situation, if the fluid is up to 5000, the mobile Hi-Jet 5th is approved and it can be used for the commercial up to 5000 pound per square inch hydraulic pressure aircraft systems. So now I will discuss about hydraulic fluids. Different types of hydraulic fluids I have just discussed, but it is only for the one nation, that is the US. Now I am going to discuss about some different countries and the NATO countries. The working fluid will be considered as a physical medium for transmitting power and the conditions under which it is expected to work. For example, maximum temperature and the maximum flow rate are described. Safety regulations bring about some differences between military and the civil aircraft fluids. So, modern military aircrafts have until recently operated exclusively on a mineral-based fluid known variously as DTD 585, this is for the United Kingdom, DTD 585, it is from UK, military H5606, which now we don't use. This is not a good. Okay. Air 320 is from the France and H515 is from the NATO. So these are the nowadays used hydraulic fluid on the different countries. Advantage of these things are it is freely available throughout the world. Mineral soil are available. These oils which I have just now described, these oils 1, 2, 3, 4, 5, DTD 585, military H5606, Air 320, H515. These are having some advantages. It is freely available throughout the world, reasonably priced, and has a low rate of change of viscosity. So, very important parameter is at high temperature, high pressure, or the low temperature also, the range of viscosity will not change much with respect to the temperature compared to the other fluids. So that is one of the best property of this thing. Being a petroleum based fluid, it is flammable and is limited to a working temperature of 130 degrees centigrade. So this is the disadvantage, that they are the petroleum product. They are likely to get fire at the earliest. One of the rare departure from the DTD 585 was made to overcome this upper temperature limit. This led to the use of DP47, known also as silicodine, in the ill-fated TSR2. So DP47, and this has happened, one accident happened in this, and by this using HDTD 585. Nowadays, the synthetic fluids are used, that is the military H83282, an entirely synthetic fluid. So by this fluid, the temperature range of operating temperature range is tremendously increased, and it is miscible with the DTD 585, and although slightly more viscous below 20 degrees centigrade, it compares well enough. So at lower temperature, the density of this component is increased tremendously. Next, I am going to discuss about the properties of the fluid. So fluid pressure. So system have become standardized at 3000 psi or 4000 psi. There have been chosen to keep weight to a minimum while staying within the body of experience built up for pumping and containing the fluid. Many studies have been undertaken by industry to raise the standard working pressure. Pressure targets have varied from 5000 psi to 8000 psi, and all resulting systems studied claim to show reduced system component mass and volume. Please take note of this. As and when we use the 3000 to 4000 psi, the system pressure is not much. The piping, the pumps, these all things are required in big size. The weight of the system will increase. But as and when we go for the higher pressure, like 5000 to 8000 psi, this results that reduced system component mass and the volume. So in the system components, mass and volume of the system component, all the parts of the component, let it be reservoir, pump, pressure, this thing, reducing valve, everything, the size of this thing will reduce. Interestingly, the DTD 585 cannot be used above 5000 psi. We cannot use this DTD 585 above the 5000 psi because of shear breakdown within the fluid. So in the fluid itself, the breakdown will take place and the shear breakdown will happen. This is obviously impractical and would preclude the common use of well-proven component and test equipment. Now, if I discuss about the temperature. So, in the previously pressure, in the olden aircraft, pressure was to use 3000 to 4000 psi. But for the modern aircraft nowadays, we started using the 5000 to 8000 psi. So if you want to use in this type of high pressure, the military H585 will not work. For that, we have to use military H8282. Same way, if you want to make a high temperature range, so with fast jet aircraft capable of sustaining operation above Mach 1, if the aircraft is flying in the supersonic zone, there are advantages in operating the system at high temperatures, but this is limited by the fluid used. For many years, the use of DTD 585 has limited temperature to about 130 degrees centigrade, and components and seals have been qualified accordingly. The use of military H83282 has raised this limit to 200 degrees centigrade. So if we use this type of fluid, this is military 838, 832, A2, then the temperature of the working temperature can be raised to 200 degrees centigrade. And many other fluids have been used from time to time. For example, on Concorde, which is a supersonic passenger aircraft, and TSR-2 to allow high temperature system to be used. So like this high performance and nowadays X-59 and all, these experimental supersonic aircraft for the passengers, they have to use the military H83282 fluid for the operation of the hydraulic system, which is able to sustain for a high temperature up to 200 degrees centigrade. Now, the third property is fluid flow rate. So, first one is the pressure, another one is temperature. Third one is the fluid flow rate. How much flow should go per unit time? How much amount of volume it is able to push towards the system. That is called the fluid flow rate. So, determination of the flow rate is a more difficult problem. When the nominal system pressure is chosen, it must be remembered that this is in fact a stall pressure. Apart from some very low quiescent leakage, no flow will be present in the circuit. The designer must allocate some realistic pressure drop, normally 20 to 25% of nominal pressure. Having established this, the pressure drop across each accumulator will be known. The aerodynamic load and the flight control laws will determine the piston area and rate of movement. The designer must then decide which actuator will be required to act simultaneously and at what speed they will move. So this we have to understand that what flow rate we have to operate the system. Now, hydraulic fluid used in aircrafts. The fluid used in aircraft hydraulic system is one of the system's most important part. The fluid must flow with a minimum of opposition, means there should be a sufficient amount of viscosity, must be incompressible, good lubricating properties, inhibit corrosion, and non-attack seals, must not foam in operation. So these are the properties which any hydraulic fluid should have. So first one is what? Minimum opposition, means the frictional forces should be very less. It should be incompressible, means it is once you are compressing this fluid, the molecule should not compress. Good lubricating properties, because it is the piston is moving again and again, so it should itself lubricate the system. Inhibit corrosion, it means that it should be corrosion resistance, rust should not be formed, and not attack seals. And the rubber seals which are inside the present, your fluid should not react with that, so that the life of the rubber seals should be maintained high and must not foam in operation. Means there should not be foam, as and when it is pressurizing, foam should not generate on this system. So these are the another properties which any hydraulic fluid should have. Characteristics of the hydraulic fluids. Some very important characteristics that must be considered are the viscosity, chemical stability, flash point, and fire point. So now I will discuss each one by one. Viscosity is the internal resistance to the flow. So what is the viscosity? Viscosity is the internal resistance to the flow. Whenever the fluid is there and anything motion is there. So motion between the fluid particles, the layers of the fluid, between two layers, this is the resistance is called the viscosity. Like gasoline or the petrol has got flow easily because it has the low viscosity. Tar flows slowly as it has the high viscosity. So if you see the tar which is put on the road, it is very, very thick. And if you are heating it, it will become somewhat liquid, but it will be very hot, very slow moving. So viscosity is very high. So this we can compare between the petrol and the tar. So petrol has got very less, so it will flow very fast. And tar has the high viscosity, the flow will be very slow. A satisfactory liquid for hydraulic system must have enough body to give a good seal at pumps. It should also, the hydraulic fluid should give a very good seal to the pumps valves and the piston, but it must not be so thick that it offers excessive resistance to flow. So the fluid should not be so thick like tar. So flow will not be there. It will stop the flow. The average hydraulic liquid has a low viscosity. So most of the hydraulic liquids, they are put with a low viscosity, not a very high, not very low like petrol also. So it should be medium viscosity. It should be there. Now next property is chemical stability. Chemical stability is the ability of the liquid to resist oxidation and deterioration for a long time. So for a long time, your fluid should resist the oxidation. Means it should not destroy the quality of liquid itself or the fluid with the oil which is there like hydraulic fluid. It should not decompose from itself. Excessive temperature have a great effect on the life of a liquid. So if you have the excessive temperature, you have the great effect on the life of the liquid. Liquids may break down if exposed to air. So this type of liquid, if put for a long time in air, they will try to break down water, salt or other impurities, and the water, salt and other impurities of the atmosphere will be present. Flash point. Flash point is the temperature at which the liquid gives off vapor in sufficient quantity to ignite momentarily when a flame is applied. So what is the flash point? Flash point is the temperature at which a liquid gives a sufficient amount of vapor in sufficient quantity to ignite momentarily when a flame is applied. So if you apply a flame, it should burn. So vapor should be sufficient on top of your hydraulic oil so that fire should not take place. So it should not evaporate much. So at high temperature only it should happen. High flash point is desirable for a hydraulic fluid. So we need a high flash point, means if you give the high temperature, then only it should try to evaporate. For a low temperature, it should not evaporate. So high flash point should be high. Next is fire point. Fire point is the temperature at which a substance gives off vapor in sufficient quantity to ignite and continue to burn when exposed to a spark or flame. So fire point, what is the fire point? It is also a temperature at which a substance gives off vapor in sufficient quantity to ignite and continue to burn when exposed to a spark or flame. So this is the temperature at which the sufficient amount of vapors are there, and if you give this small spark, it will start burning and it will continue burn. In fire point, in flash point, it will not continue burn. Okay, that is the difference. So fire point is higher than the flash point. So high fire point is required of desirable hydraulic fluids. So if you want a good hydraulic fluid, a high fire point and high flash point should be there so that it can resist the fire, and fire should not take place, because you know that at high altitude you don't have any firefighter. You cannot make a truck to expose the fire on the system. Now another types of hydraulic fluids, we have seen the vegetable base, mineral base and synthetic base. Normally we don't use the vegetable base because its flash point and the fire point are very less. We use the mineral base, but mineral base are also in a medium flash point and the fire point. But if you use the synthetic fluids, the fire point is quite higher. Flash point and the fire points are quite higher. However, everyone has got some disadvantages. Like mineral base, they are very good for a low temperature. But synthetic fluids are not very good for a low temperature. They are very good for a high temperature, because mineral based are on the petroleum product. But this synthetic fluids are not petroleum product. They are mixed with some phosphate and other material, so that it becomes a less fire risk. So we have discussed earlier also. So in this, military H5606 is the most widely used hydraulic fluid in general aviation aircraft. So this H5606 is used for small aircrafts, kerosene type petroleum product, and this 5606 is what? It is like a kerosene, petroleum product, dyed red for identification. So it is looking like a reddish, so that you can identify that it is a 5606. Now if I talk about the synthetic fluids, they are the non-petroleum based hydraulic fluids for use in high performance piston engine and turbine powered aircraft. So these are used because piston engine and the turbine are rotating with a very high temperature. So there we have to use the synthetic fluids. Most commonly used fluids of this type is scoidrol. I have discussed this thing. Scoidrols are used normally for this type of situation, colored light purple. If you see, the previous one is the red one, dyed red, but this one, synthetic fluids, they are the purple in color. So by the color itself, you can identify this is for the synthetic fluid and this is for the mineral. And so we should not mix synthetic fluid and the mineral fluid, so that you can identify that by the color itself that this is the synthetic and this is the mineral. Now hydraulic fluid requirements, we have the functional requirements. Your hydraulic fluid should be good lubrication characteristics. Viscosity should not depend strongly on the temperature and the pressure. Good heat conductivity, low heat expansion coefficient, large elasticity modulus. Economic, it is a low priced, low aging, thermal and the chemical stability. Safety, it is high flash point or in certain cases not inflammable at all. Chemically neutral, not aggressive at all against all materials in touches. Low air dissolving capability, not inclined to foam formation. So it is not even trying to form the foam also. Environmental friendliness, no environmental harm and no toxic effect. So these properties should be there for any hydraulic system. Next is job performed by the hydraulic fluids. So what are the jobs hydraulic fluids perform? They have the following primary tasks: power transmission, pressure and motion transmission. So first work is to transfer the pressure and the motion of the system, and then signal transmission for the control. So if you want to make something, you have to give the signal, so hydraulic fluid will open or the close of the system. These are the two primary tasks, but we also have some secondary tasks like lubrication of rotating and translating component to avoid friction and the wear. Heat transport away from location of heat generation, usually into the reservoir. Transport of particles to the filter. Protection of surface from chemical attack, especially corrosion. It should not happen. Properties of hydraulic fluids, it should be good lubricity. It should be able to lubricate properly. It should also have stable viscosity characteristics as per the temperature of the surrounding and the system. Your hydraulic fluid should behave in a proper way. Good heat dissipation. It should also dissipate the heat which is absorbed during the operation. It should be able to release the heat, otherwise the temperature will be high and the fire will take place. Flash point we have discussed. Low foaming tendency we have already discussed. Fire resistance, it should be a fire resistance. Prevent rust. Corrosion should not take place. It should be also non-toxic, easy to handle and available. So what is the meaning of good lubricity? Means it should be able to lubricate the gears transmission system very, very easily. It is shown here. Just you can see, this is the fluid, hydraulic fluid. So if this is a gear and here is a pinion, so if this is rotating, gear will also rotate, or the gear is rotating, this will also rotate. In between this, the friction may take place here. So this oil should always be poured here, and it should be properly lubricating so that the friction should not generate more. Okay, so this is the purpose of the good lubricity. So the component in a hydraulic system contain many surfaces which are in close contact and which move in relation to each other. The hydraulic fluid must separate and lubricate each surfaces. So each surface your hydraulic fluid should lubricate, and it should also try to extract the heat, and also whenever it is cooled, the heat of this oil should be extracted very easily. Protection against wear is a principal reason for selecting a fluid having good lubrication characteristics as a hydraulic medium. So it is one of the primary requirement that it should be able to lubricate the system where it is working. Second one is good heat dissipation. Here I have shown that if the fluid is entering from here and it is taking the heat from here, it should also try to take out the heat from the system where it is entering. So an important requirement of the fluid is to carry heat away from the working parts. So wherever you want to lubricate or you want to use this fluid, whatever heat is there, it should be able to take away. Pressure drop, mechanical friction, fluid friction, leakage, all generate heat. So if the pressure is dropping, it will generate the heat. If the mechanical friction is there, it will generate the heat. If there is a friction between the fluid, there will be heat. If there is a leakage, heat will be there. All generates heat. These all generates heat. So the fluid must carry the generated heat away and readily dissipate it to the atmospheric or cooler. Therefore, high thermal conductivity and high specific heat value are desirable in the fluid chosen. Next is flash point. This you can see here. Here gasoline, fluid is evaporating here. But if you see the fuel oil, the 125 degree Fahrenheit and it is minus 60 Fahrenheit. If you take the petrol, it is minus 40 degree Fahrenheit and it is 125 degree Fahrenheit also. In the fuel, it is not there. Okay. So the flash point of a hydraulic oil is defined as the temperature at which flashes will be generated when oil is brought into the contact with any heated matter, for example, a heat sink. Low flash point oil are not used as hydraulic oil. So we cannot use this gasoline as a hydraulic oil because it is having low flash point. We need a oil which is having high flash point. This type of oil we can use for the hydraulic system. Okay, that is the benefit of this. Next is low forming tendency. Just you can see here bubbles in this diagram. There are some bubbles. So if your system is working, it should not form like these bubbles. If it is forming, it is not good. So foam results from air or other gases becoming entrained in the hydraulic fluid. Air enters a hydraulic system through the reservoir or through air leaks within the system. A hydraulic fluid under high pressure can contain a large volume of dissolved or dispersed air bubbles. When this fluid is depressurized, the air bubble expands and produces foam. Because of its compressibility and poor lubricating properties, foam can seriously affect the operation and lubrication of machinery. Proper foam inhibitors modify the surface tension on air bubbles so they more easily break up. So here there is a surface tension for each bubble. There will be different surface tension, and proper inhibitors we have to use so that it should not form the foam bubbles. Next is the fire resistance. Fire resistance is one of the properties that is optional in a good usable hydraulic fluid. It is very important that the hydraulic fluid should be fire resistant. Fire resistance is one of the properties that is optional in a good usable hydraulic fluid. The commonly used hydraulic liquids are petroleum derivatives, and consequently they burn vigorously and they pass the point. For critical application, artificial or synthetic hydraulic fluids are used which have high fire resistances. various grades of fluids with high water contents are also available nowadays for oil hydraulic systems. Okay, so various grades of fluids with high water content are also available nowadays for oil hydraulic system. Next, we should see here, this is the diagram here. So this you can see the fire resistance. Fire should not take place. So we should use such a way. Now, if you see here, we have here two diagram here. Stable viscosity means it is a good one, and this is the used one. So the color should not change. The viscosity of this thing, it should be quite dense as it is. It is very weak here. So our fluid should be like this. Viscosity is a measure of hydraulic fluid resistance to flow. It is a hydraulic fluid's most important characteristics and has a significant impact on the operation of the system. So this viscosity is very important. If the viscosity is losing, the system performance will be tremendously reduced and component failures will start. When a hydraulic oil is too thin, low viscosity, it does not seal sufficiently. So the sealing capacity of this oil will be reduced. This leads to leakage and wear of the parts. So it will start the leakage and the wear and tear of the parts will start. When a hydraulic oil is too thick, means high viscosity, the fluid will be more difficult to pump through the system and may reduce operating efficiency. If the viscosity is high, then also it will be difficult to pump and it will reduce the operating efficiency of the system. All hydraulic fluid must be able to retain optimum viscosity during operation in cold or hot temperature in order to consistently and efficiently transmit power. All hydraulic fluid must be able to retain optimum viscosity during operation in cold or hot temperature in order to consistently and efficiently transmit the power. Next, it is also very important that we should have the non-corrosive properties of this thing. Is it should be corrosion resistance. Corrosion should not take place, rust should not take place whenever this hydraulic fluid is used. In many systems, water can enter as condensation or contamination and mix with the hydraulic oil. Water can cause rusting of hydraulic component. In addition, water can react with some additives to form a chemical species which can be aggressively to yellow metals. Hydraulic oil formulations contain rust and corrosion inhibitor. So in hydraulic fluid, what? We have to use rust and the corrosion inhibitors. There are some materials which are mixed in the oil so that rust and the corrosion should not take place wherever this hydraulic fluid is used, which prevents the interaction of water or other chemical species from attacking metal surfaces. So we should make sure that the hydraulic system where we are using, it should be very much corrosion resistance. Rust should not form. So we have to mix some inhibitors. Those inhibitors are preventing to form the rust on the system. It should also be non-toxic. It should not be poisonous. It should not be harmful to the creature, plants or animals or human being. These characteristics refers to the interaction of the fluid with people who repair, handle, use or pay for hydraulic system. Means those who are working, those who are nearby the system, they should not feel any toxicity of this thing. It should be non-flammable. Obviously, it is desirable that the fluid be as simple to handle and as available and cheap as possible. Obviously, it is desirable that the fluid be as simple to handle and as available and cheap as possible. So these are the very important properties that our hydraulic system should have. Typical fluid power system, it is shown here. It is an actuator here. This you can see. This is the actuator. This is the selection valve. And here is the pump. NRV, filters, all things are there. And here also, if you see here, this is a compressed one. It is a pneumatic system. So here this you have the reservoir. This is the reservoir. All simple hand operated. It is shown here. And this I have already discussed in my previous classes. And so here we have some component like this is the reservoir here. Here also this is the pump, filter. Here NRV, shut-off valve, pressure reducing valve, selector valve. This is the actuator. Here is the accumulator. Above is the nitrogen and below is the hydraulic system. And again it is the filter. And here this you can see the hydraulic tank. And here we have the pump. Also this we can see here that actuators, accumulators are here, fire filters are here, sequence valves are priority valves. These all things I have discussed. Next we will discuss about hydraulic piping, pumps, reservoirs and the actuators in my next class. Okay, so these are the references which I have used in this lecture. Moyer and the Seabridge, aircraft systems, mechanical, electrical and avionics system. Another book is from Moyer and Seabridge again, Design and Development of Aircraft Systems and Introduction, AIAA Education Series, AIAA. Any questions you are welcome to ask to me. It will be very nice if you can mail me if you have any problem in this my mail. gmail.com. So this is my mail and you are welcome to ask any questions. Hope you have understood. Please subscribe and like this video so that I will get some response from your side. Any questions you can give in the comment box also. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.